We know you've heard a lot already about the outbreak of coronavirus. However, we hope to teach you something the news hasn't already. In this presentation, we will briefly discuss the molecular effect of COVID-19 within the body, what effect it has globally, and how best to tackle it.
Coronaviruses are a large viral family that cause illnesses ranging from the common cold to the more severe diseases such as the Middle East Respiratory Syndrome, otherwise known as the MERS, and the Severe Acute Respiratory Syndrome, otherwise known as SARS, which were large epidemics in 2012 and 2002, respectively. A novel coronavirus is a new strain that has not been previously identified in humans, namely the one that we are dealing with right now.
Coronaviruses are zoonotic, meaning they are transmitted between animals and people. MERS, which was transmitted from touching infected camels or consuming their meat or milk, was first reported in 2012 in Saudi Arabia and has mostly been contained in the Arabian Peninsula. SARS was first reported in 2002 in southern China. No new cases have been reported since 2004 and is thought to have spread from bats that infected civet cats.
The new coronavirus was likely transmitted from touching or eating an infected animal in the Wuhan market in December of 2019.
The main parts of the viral particle is the spike protein, the nuclear envelope, the HE group, and the genetic information. According to scientist Wiesler, the spike is most important where viral entry is concerned. It is in charge not only of attachment of the host cell surface, but also of fusing the viral and host cell membranes to allow the infection to start. The nuclear envelope, therefore, helps to keep the spikes attached in a membrane-style fashion. The HE protein, otherwise known as the hemagglutinin esterase, forms distinct inner fringes of short peptimers. And finally is the RNA and the N protein, components which enable coronaviruses to transfer their genetic information upon replication. Although the infection pathway of the latest coronavirus strand is not yet known, the structural similarity of the strands and common nature of viral replication enables us to hypothesize how this newest strand enters the host. The first step is that the virus enters target cells through an endosomal pathway. An S protein first binds to the cellular receptor angiotensin converting enzyme 2, known as ACE2 receptor, via the spike protein, translocating the ACE2 virus complex to endosomes, where S protein is cleaved by proteases to activate its fusion activity. Virus entry into the host cell can occur through fusion within the surface of the host cell, leading to release of the RNA into the cytoplasm. Then, the viral genome is released and translated into viral replicase polyproteins, which are then cleaved into smaller products by viral proteinases. Viral nucleocapsids are assembled from genomic RNA and N protein in the cytoplasm, followed by budding into the lumen of the endoplasmic reticulum, Golgi intermediate compartment. Virions are then released from the cell through exocytosis, causing the released virus to infect other cells. The ACE2 molecule, which is used as a receptor by a relatively non-harmful coronavirus strand, HCOV-NL63, as well as SARS, has been associated with respiratory disease.
The ACE2 receptor is also involved in protection against lung damage, which is intriguing, and it suggests opportunities to treat complications during respiratory tract infections.
The fact that these two strands of coronavirus use the same receptor while their pathogenicity and disease courses are utterly different calls for detailed comparisons of the immune responses, inflammation processes, and in vivo replication characteristics of these two viruses. The protein NSP15 from COVID-19 is 89% identical to the protein from the earlier outbreak of SARS-CoV, as both viruses belong to the beta genus of the coronavirus family. Studies published in 2010 on SARS-CoV reveal that the inhibition of NSP15 can slow viral replication. This suggests that drugs designed to target NSP15 could be developed as effective drugs against COVID-19 also.
COVID-19 severity has evidently been shown by the fact that people from more than 50 different countries have been affected with it, and the stats involving more than 186,000 cases with over 7,000 deaths.
During the SARS outbreak, the virus killed about 1 in 10 people who were infected. The death rate from COVID-19 isn't yet known. In the beginning of an outbreak, the initial cases that are identified are skewed to the severe, which may make the mortality rate seem higher than it is. The mortality rate may drop as more mild cases are identified, such as the 80,000 and over cases that have recovered already to this day.
Currently, most of the patients who have died from the infection have been older than 60 and have had pre-existing conditions. This also involves infants with continuously developing immune systems and adults with weakened immune systems due to underlying health conditions such as cancer or respiratory diseases.
If we focus on the increased likelihood of the elderly getting affected, we can compare figures between two of the most highly affected countries in the world, China and Italy.
Italy has a large aging population compared to China, who has a young population, especially considering their massive baby booms over the past century in comparison to Italy. If we disregard underlying health conditions and just focus on the elderly and how this virus affects them, we find that 21.69% of Italy's population is 65 and over, whereas in China, this is nearly halved, with figures standing at 11.27%.
The Chinese population is 1.3 billion compared with the 61 million in Italy. As of now, around 3,000 deaths have occurred in China compared with the 2,000 in Italy. This is why, when comparing these death rates of COVID-19 in proportion of the populations, it may come as an initial shock. However, it isn't surprising, considering when it comes to statistically proportioning the numbers, a higher amount of elderly citizens reside in Italy and so are more vulnerable of getting it.
An example of a current case is a 48-year-old woman from Ohio, Miss Driscoll. She stated that she went home after feeling sick at her workplace, and when taking a temperature, it was 37.2 degrees, which was normal. However, she woke up at 3 in the morning coughing, and she felt her chest constricting and a fever of 38.8 degrees. Driscoll, currently under quarantine, says that her health is improving. However, she still feels exhausted, plus is dealing with symptoms, for example, fatigue and mild headaches. Another case is of Miss Schneider, a bioengineer and a resident of Seattle, started feeling sick a few days after attending a party. The 37-year-old's body ached and her temperature rose to 39.4 degrees. She had chills and a headache. She thought she didn't have the coronavirus because she wasn't experiencing a cough or shortness of breath, the most common symptoms of the virus. It wasn't until March the 7th, almost 2 weeks later, that Schneider got the call that she had tested positive for COVID-19. These two cases alone show how differently the virus can affect individuals within the population and that it has a large variety of symptoms.
There are a few ways that a lab may get a sample for the testing of coronavirus. The first is a swab test, which uses a special swab to take a sample from your nose or throat.
The second way is known as a nasal aspirate, which is basically an injection of a saline solution into your nose, and then you remove the sample with a gentle suction.
The third is tracheal aspirate. A healthcare provider will put a thin, lighted tube called a bronchoscope down your mouth and into your lungs, where a sample will be collected.
A sputum test is the fourth way, and sputum is a thick mucus that's coughed up from the lungs, and you may be asked to cough up sputum into a special cup, or a special swab may be used to take a sample from your nose.
The final method is a blood test. A blood sample can be taken from a vein in your arm. The FDA has approved more widespread use of a rapid test for COVID-19. The test, which was developed by the CDC, uses samples from the nose, throat, or lungs, which enables fast, accurate diagnosis of the virus. The test is now allowed to be used at any CDC-approved lab across the country. Right now, all we can do is try to prevent and delay the viral spread, and we can best do this by implementing the following effective methods.
So the first method is known as social distancing, which, as advised by Boris Johnson, includes a 14-day isolation for all households with mild symptoms such as a cough or a sore throat. A warning against non-essential contact was also given, which included trips to pubs and clubs and to end to all mass gatherings.
Recently, a Wuhan doctor has stated that vitamin C is also an incredible, useful vitamin supplement to take after seeing the reduced effects and symptoms it had on a family of 5 struck by the disease. It increases hydrogen peroxide levels in the body, which helps to reduce the duplication of viral particles.
The fairly obvious one is known as the washing of hands, which is the most effective and effortless way to maintain basic hygiene.
And finally, and most importantly, working together as a local and global community. An example of this is the recent creation of buddy schemes to help the elderly and those that are too immunocompromised to leave the house in order to combat self-isolation.